Okay, get ready to dive deep because we're tackling your latest fascination, the hunt for life beyond Earth. You've really been digging into exoplanets, huh? And let me tell you, there is a ton to uncover.
Yeah, it's a pretty captivating field.
Definitely captivating. And you haven't just skimmed the surface. Those ESA articles, that deep dive on SETI, on Wikipedia, even that interview with Douglas Lynn in Oxford Academic, you're ready to go deep on this.
Uh,
I like it.
It's amazing how much is out there. Every new discovery just seems to open up even more questions.
Exactly. It's like every day we hear about a new planet being discovered. In fact, I think it was that Oxford article that said exoplanet research has been growing, get this, exponentially over the last 30 years. And exponentially, that's not just a fancy sciencey word.
Right, it means we're in the middle of a full-blown discovery boom.
Exactly, a boom. So, to help us break down this boom, why don't you give us a little context? What's changed? Why now?
Well, for a long time, it was all just theory, right? Like, could there even be planets beyond our solar system? But what's really exciting now is that we actually have the technology to go beyond the theory.
We're actually finding them.
Yeah. We've got these incredible telescopes like Kepler and TESS sending us back mind-boggling amounts of data. But it's more than just the tech, right? What's got me really fired up is the global community. It's like we've got this whole network of researchers all collaborating, all pushing each other to ask bigger, bolder questions.
I like how you put that bigger boulder. It's like a chain reaction of new discoveries.
Exactly. It's why that Oxford article called it a golden age of exoplanet research. And I gotta say, I'm pretty darn excited to be a part of it.
You and me both. So, what exactly has you so fired up? What's got you on the edge of your seat?
Well, think about it. We're talking about planets trillions and trillions of miles away. Many of them are too faint to see directly,
Hmm?
but we've figured out ways to find them.
It's mind-boggling. So how do we do it? How do we hunt down planets we can't even see?
So there are three main methods, each with its own clever approach. You want to unpack those a bit?
Lay it on me. What's method number one?
All right, so the first method is direct imaging. Imagine this. You're trying to spot a firefly, but it's right next to a spotlight. That's basically what it's like trying to see a planet next to a blazing star.
Yeah, good luck with that. Talk about a challenge.
Right, but it's possible. Then there's another method, the radial velocity method. Now, this one's based on the idea that a planet's gravity will actually cause its star to wobble ever so slightly.
Hold on, we can detect that. These tiny movements from light years away.
You got it. It's pretty amazing.
Mm-hmm.
But the method that really blows my mind is the transit method. Okay, picture this. You're at a rock concert, yeah, and there are those giant spotlights behind the band. Now, as the lead singer, with the big hair, walks across the stage,
I think I see where you're going with this.
exactly,
Yep.
you only see their silhouette passing in front of the light. The transit method works kind of like that.
Okay, so the planet, is that the lead singer with the big hair?
You got it. The planet is our big-haired rock star. So when it passes between us and its star, it blocks out a teeny tiny bit of the star's light, just like our rock star blocking the spotlight. And we can actually detect these dips in brightness.
And from those dips, we can tell what exactly?
We can figure out the planet's size, how long it takes to orbit its star. It's incredibly precise.
That is so cool. It makes you wonder, though, if it's this simple, how did we miss these exoplanets for so long?
It's a great question. I think for a long time, our telescopes just weren't sensitive enough to detect these super subtle changes in light. And we're talking about a ridiculous amount of data here. It's really only been recently that we've had the computing power to crunch all those numbers effectively.
It's a good reminder that sometimes it's not about having the fanciest tech, but about using what we have in a really innovative way.
Couldn't agree more.
Which actually reminds me of that story in the Oxford article, about the exoplanet found with a telescope in a Denver parking lot.
Oh, yeah. That one always blows my mind.
Talk about a low-tech win.
It just shows you, right?
Yeah.
Groundbreaking discoveries can happen in the most unexpected places. Sometimes all you need is a frank perspective and a good dose of curiosity.
That parking lot telescope is a great reminder that we're really just starting to scratch the surface when it comes to the cosmos. And, we've been talking about finding these planets, but the real holy grail here is figuring out if we're alone in the universe, right?
Absolutely. That's the big question.
And that's where things get even more interesting, especially because you mentioned being curious about the possibility of life as we don't know it.
It's a question that has fascinated, scientists and philosophers for centuries.
Yeah, for sure.
And as we're discovering this incredible diversity of exoplanets out there, it just becomes even more intriguing.
Like, how do we even wrap our heads around it?
Right. And before we can even start looking for alien life, I think we need to grapple with a pretty fundamental question.
Boy, it
What
is.
is life, anyway?
Hmm. That seems like a deceptively simple question.
Right. We tend to think of life as we know it here on Earth. Carbon-based, needs water, breathe oxygen, all that.
Yeah.
But what if those are just Earth-centric biases? What if life out there doesn't follow our rules?
What if it's something we can't even imagine?
Exactly. It's like Douglas Lynn said in that Oxford article, defining life is a moving target. He even used the example of artificial intelligence.
Oh, so?
Well, think about it. A sufficiently advanced AI, right? One that's capable of self-assembly and self-reproduction.
So it can basically build itself and create copies of itself, starting to sound a lot like life.
Right. It really makes you question our traditional definitions.
And really makes this search for extraterrestrial life even more complex. It's not just about finding life, it's about defining what life even means.
100%.
Yeah.
And while a lot of the focus is still on finding those classic biosignatures, those signs of life as we know it, like, the presence of oxygen in a planet's atmosphere, things like that.
We got to be ready for some curveballs.
Exactly. What if alien life has evolved to thrive in environments we consider completely hostile? Like, those methane-rich atmospheres we talked about earlier.
Right. So how do we even begin to look for something that might be completely different from anything we've ever encountered?
Well, it's a huge challenge, but I think Lynn offers a really good perspective on this, too.
Okay, what's his take?
He argues that, even just finding microbial life, those tiny single-celled organisms, that would be a game changer in itself.
Why is that?
Because it would prove that life on Earth isn't some crazy fluke. It would mean that life can arise in other corners of the universe.
That's huge. That would completely change our understanding of, well, everything.
I know, and he reminds us to stay open to all the possibilities.
Don't get stuck in our Earth-centric ways of thinking.
Yeah. I mean, he even quotes that song, what is it? Don't worry, be happy. I love it.
It's a good mantra to have when you're talking about something as vast and mysterious as the universe. So we're scouring the cosmos for signs of life, big or small. And meanwhile, there's another player in this field that I know you're curious about, China.
Oh, absolutely. They're definitely a force to be reckoned with.
They've been making some serious waves in space exploration, so where do they fit into this whole exoplanet hunt?
Well, let me tell you, China is quickly becoming a major player in this field. And get this, they're not just adopting existing methods. They're developing their own innovative techniques and technologies. They're not messing around.
Okay, color me intrigued. What kind of innovations are we talking about?
Well, they're using the transit method we talked about, of course, but they're also exploring this really fascinating technique called microlensing.
Microlensing. Okay, I'm going to need you to break that one down for me.
Okay, so basically imagine a planet's gravity is so strong that it can actually bend and magnify the light from a more distant star that's passing behind it.
Okay, so we're talking about some serious gravitational lensing here.
Yeah, you got it. It's like using a cosmic magnifying glass to spot those really faint, really far away planets.
That's incredible. They're basically manipulating the fabric of space-time to find these planets.
And it's not just the techniques, right? They've got
Yeah.
some seriously impressive hardware to back it up, too.
Well, let's hear about it. What have they got?
Okay, so first up, they have this thing called the 500-meter aperture spherical radio telescope,
Oh,
or FAST for short.
catchy name.
Right. It's the world's largest single-dish radio telescope,
The largest.
the largest. And it could potentially detect those super faint signals from, well, alien civilizations.
Okay, now we're talking. So what else?
Well, they've also got their incredibly ambitious Earth 2.0 mission.
Earth 2.0. That sounds like something straight out of a sci-fi movie.
Right. The goal is to find an Earth-like planet in a habitable zone around a sun-like star. They're really going for it.
It's ambitious, but hey, you miss 100% of the shots you don't take, right? It's clear that China is serious about pushing the boundaries of what we know about exoplanets and the potential for life beyond Earth. It's incredible to think we might actually find another Earth out there. But, building a world-class space program like China's, it takes more than just fancy telescopes and technology, right?
Absolutely. At the end of the day, it all comes down to the people, the brains behind the operation.
And I think it was that Oxford article that mentioned China might be facing some challenges in that department, something about a shortage of experts.
Yeah, it's something
Mhm.
Douglas Lynn touched on. He's been super involved in building those scientific bridges with China, even helped set up a research institute at Peking University. He pointed out that while China's academic system is incredibly competitive, which is great, it can sometimes make it tricky for researchers to really collaborate openly. It's a different kind of research environment.
It's interesting how cultural and systemic factors play into something as seemingly remote as space exploration? It's not just about the science, it's about the people doing the science.
100%. And, while China's making incredible progress on the exoplanet front, they're not putting all their eggs in one basket. They're also putting a lot of energy into exploring our own solar system. Mars, the moon, they've got their sights set on it
It's
all.
like they're playing the field.
In a way, yeah. They're exploring all avenues. They're even looking at potentially getting involved with the 30-meter telescope project.
Yeah, that's a game changer. That's a massive international collaboration.
Huge,
It's encouraging to see that even with all the, geopolitical stuff going on, the pursuit of knowledge can still bring people together.
for sure. It reminds me of something else Lynn said in the article about how the problems we face here on Earth, things like climate change, they're actually giving us this deeper understanding of what makes a planet habitable in the first place.
So our search for life beyond Earth is actually intertwined with the fate of our own planet.
Exactly. It's this feedback loop, right?
Hmm.
Every exoplanet we discover, every atmosphere we analyze, it teaches us something new about that delicate balance, that recipe for life. Amazing, really.
We started this whole deep dive talking about those mysterious interstellar objects like Oumuamua zooming through our solar system.
Wild, right?
It's like they're little postcards from other star systems reminding us just how much we don't know. And it really makes you wonder, what if those objects are more than just rocks and ice?
Here we go.
What if they hold clues to alien civilizations, whispering tales of technologies beyond our wildest dreams? It's a pretty mind-blowing thought to end on, don't you think?
Definitely mind-blowing. Makes you want to get out there and explore even more.
Exactly. And that's what it's all about, right? Never losing that sense of wonder. This deep dive might be over, but who knows what incredible discoveries await us out there in the vastness of space. Keep looking up and keep asking those big questions. You never know what you might find.